Measure of skewness. Objective: determine the measure of skewness. Identify the frequently used methods in measuring. Based from the previous topics that we've encountered, skewness is a measure of asymmetry or distortion of symmetric distribution. It measures the deviation of the given distribution of a random variable. We have here the graph that tells if it is positively skewed, negatively skewed, or if it has zero skewness. You can see that in the positive skewness, the given distribution is shifted to the left with its tail on the right side. You can see that in the negative skewness, the given distribution is shifted to the right with its tail on the left side. Lastly, in the zero skewness, also considered a normal distribution as it is symmetrical on both sides. Hence, a curve is regarded as skewed if it is shifted towards the right or the left. The mean, median, and mode can be used to figure out the skewness of the distribution. Measure of skewness. The two frequently used methods are Pearson mode skewness and Pearson median skewness. The Pearson mode skewness, also called Pearson's first coefficient of skewness, used when a strong mode is exhibited by the sample data. The Pearson mode skewness formula: mean minus mode over the standard deviation, where x bar symbol is the mean, MO is the mode, sigma symbol is the standard deviation. The Pearson median skewness, also called Pearson's second coefficient of skewness, used if the data includes multiple modes or a weak mode. The Pearson median skewness formula: 3 times the difference between the mean and the median over the standard deviation, where x bar symbol is the mean, MD is the median, sigma symbol is the standard deviation. Let's have some examples. Example: find the measure of skewness with the following data sets: 20, 21, 21, 21, 22, 24, 25. Since there is a strong mode exhibited, we are going to use the Pearson mode skewness. We will look for the mean, mode, and the standard deviation. Mean is equal to the summation of x over n. So, 20 plus 21 plus 21 plus 21 plus 22 plus 24 plus 25 over 7 is equals to 154 over 7 or 22. For the mode, the value that appears the most frequent is the 21. Standard deviation is equal to the square root of the summation of x minus mean squared over n minus 1. So, the square root of 20 minus 22 squared plus 21 minus 22 squared plus 21 minus 22 squared plus 21 minus 22 squared plus 22 minus 22 squared plus 24 minus 22 squared plus 25 minus 22 squared over 7 minus 1 is equal to the square root of 4 plus 1 plus 1 plus 1 plus 0 plus 4 plus 9 over 6. So we got now the square root of 20 over 6 or square root of 3 over 33. The final answer is 1.82. Now that we have the mean, mode, and the standard deviation, we can now look for the skewness using the formula of the Pearson's mode skewness. Mean minus mode over the standard deviation: 22 minus 21 over 1.82. 1 over 1.82 is equals to 0.55. Therefore, there is a positive skewness, 0.55. Another example: you have data with a mean of 12.2, a median of 14, and standard deviation of 10.85. Find the measure of skewness. Since the given are the mean, median, and standard deviation, we will be using the formula of the Pearson median skewness. Formula: 3 times the difference of mean and median over the standard deviation. 3 times the difference of 12.2 and 14 over 10.85. 3 times negative 1.8 over 10.85. Negative 5.4 over 10.85 is equals to negative 0.50. Therefore, there is a negative skewness, negative 0.50. Another example, what is the measure of skewness if you have the mean of 5, a median of 5, and a standard deviation of 2.27? Just like example number 2, we will use the formula of the person median skewness based from the given. 3 times the difference of mean and median over the standard deviation. 3 times 5 minus 5 over 2.27. 3 times 0 over 2.27. 0 over 2.27 equals to 0. Therefore, there is a zero skewness, also considered a normal distribution. Thus, if the mean is greater than the mode, it is positively skewed. If the mean is less than the mode, it is negatively skewed. If the mean is greater than the median, it is positively skewed. If the mean is less than the median, it is negatively skewed. Conclusion: the difference between the mean and mode, or mean and median, will tell you how far the distribution departs from symmetry. The importance of topic in relation to real-world phenomena. It helps to understand where the most information is lying. Analyze outliers in the given datasets, just like when measuring the measurements of the performance of investment returns. The investor uses it when analyzing the dataset as it considers the extreme of the distribution. Try this.